Hey, what up, guys? We're going to be doing how to graph sine and cosine. That's kind of the goal here. So, concept overview first. If you want to hop right into the questions that were assigned, feel free to skip this first part. This is just going to be a short little lesson how to graph your sine and cosine functions. So, first of all, the big concept that we need to talk about first is what we are actually graphing. We are graphing. I'm going to go ahead and begin at 0. I will not be talking about what happens less than 0 at the moment. However, on our regular axis, that is normally the x-axis, this is theta. That is to say, our input value now is going to be an angle of some kind, and our output value will still be a y value that we will call f of x. And I'm going to go ahead and start by graphing the sine of theta function. I don't know why I wrote f of x. It really should have been f of theta. My brain kind of just failed immediately right at the start of the video. So we're going to keep on moving though. So this is what's going to happen. We're going to start off here at a y value of 0, and something is going to happen. Most likely, you were first introduced to sine and cosine by this beautiful thing I'm going to put up on the screen here. Oh yeah, the unit circle. Maybe you don't find it so beautiful. Maybe you should have had a warning before that showed up, but that's not what happened. We're looking at the y value here. So we're looking at this value over here, that y value of 0. That's where we're starting. So we're starting off at that right-hand side when it's 0 degrees, 0 radians, and we are moving along this circle from left to right, and we're going to go all the way around. The y value is defined as sine of x. Sine of x is the y. If you want to figure out why it's the sine of x, you can look at a previous video that we did, but we're going to look at this. It's going to go ahead and go up. It's going to go up to 1/2, and then rad 2 over 2, and then rad 3 over 2, and then to 1. So let's just go ahead and check out what's going on with that. We're going to start off, again, it goes 0, half, rad 2 over 2, rad 3 over 2, and 1. So effectively, what's happening is we are going to start off at 0, and then it is slowly going to, or kind of quickly, it's going to go up, and then it's going to taper off, and it's going to kind of flatten out here. And it's going to go up just like so. These values that I did, I kind of guesstimated exactly where they are. This is not a perfect graph, but that's going to happen at pi over 6, that first value that's exactly a halfway mark. So that was supposed to be at 0.5. And then over here, our next value that'll show up on our unit circle is pi over 4. That is, in terms of decimals, when we do the sine of pi over 4, you'll get rad 2 over 2, which is approximately 0.707. We're going to continue up to the next value, just barely above that. We'll be at pi over 3, and that's going to be 0.866. And then finally, all the way up here is going to be 1. You can even see it at pi over 2. So what in the world am I talking about with these 0.707? Well, that's just the approximation of rad 2 over 2. This is the approximation of rad 3 over 2. You can even make out that 3. But the point is when you're going in a unit circle, it starts off at 0, goes up, goes up, goes up, goes to 1. Now, if you notice, the y value is changing more at this first little 30-degree section than it is in this next 30-degree section, the pi over 6 to pi over 3. It goes up a whole bunch, and then it goes up only a little, and then it goes up only a smidgen right at the end. That concept of increasing a bunch and then less and less and less, so we talked about more in calculus, that's the concavity of the situation. But the point is it's going from 0 to 1, and then it goes back down to 0 in exactly a symmetrical fashion. So it's going to go back down to 0. I'm not going to mark up every single coordinate on there, but it's going back down to 0. And then after you get back down to 0, that's going to be at pi. So it happens exactly at pi, and this is supposed to be divided exactly in half. Not exactly perfect on my picture, but the point is it does that. And then it's going to go below the axis. Looking back at our little unit circle here, going back at this guy, we're going to go back below the axis. It's going now 0, and then negatives, 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 goes to -1, and then back to 0 again. The point is we are going all the way down, back, and back to the center at 2 pi. One of these guys is called a complete cycle. We call this complete cycle, a couple different words for it. I like saying complete cycle because it kind of makes the most sense, but the exact word for it that we'll use in the math class is typically the word period, how long it takes to repeat the entire process. So a complete cycle is a period, and that's going to be 2 pi for a regular situation. Other things that'll be important for us on these graphs will come up in a little bit, and that's what we're going to do. But before I do that, I don't do this entire thing for cosine as well, but the idea is it starts off at 1, and then it goes to 0 and goes back down. So if you're trying to look at that in a picture, stolen right from Wikipedia, just like that unit circle is this cute little GIF. The idea is you can follow the sine function here, and we're starting off at 0, and then as it goes up, and then down, you can see the actual sine values going up and down. And it's going up, it's going down. Cosine's a little bit different though. So let's look at this. We're going to start right, boom, right there. Cosine starting at the far right-hand side. It actually starts off way at the top up there when it's right there, and then it starts going back down. You can look at this and be mesmerized a little bit later if you feel like it. I don't think it's too big of a deal. So anyways, here's the basics of it. But more importantly, what's going to happen with all the different values that could show up, the A, B, C's, and D's, the amplitudes, and whatnot for the function. Let's check it out. So in a regular old function, we have y equals, and now I need to grab up 4 colors, which I don't even have ready. We'll get pink and purple and blue and green. Beautiful. I got 4 colors here. Those 4 colors are going to help me with this thing. We're going to go ahead and go an A, and then the sign of parentheses. I'll use the letter B for the green one, parentheses, theta plus, and then the letter C. Is that blue enough? It's going to have to be blue enough. And then end the parentheses, and then plus we'll use purple for that letter D out here. So we have 4 different letters here. All 4 of these letters are going to have a definition for us, or at least some version of a definition. The letter A is going to be equal to the amplitude. In terms of what that means, in real life, the amplitude talks about how loud something is, or how powerful a light wave is, something like that. The amplitude, how far up and down something is going. Visually on our graph, we'll be marking a little bit later, but it's how far you're going from the middle to the top. We'll be marking that up in just a moment. So in some sense, we're going to go ahead and start. It is going to be, in terms of an actual definition, it is going to be the distance from what we're going to be calling the center line or the midline to the top or bottom. It doesn't really matter. The letter B. The letter B is actually doesn't show up on the graph per se. The graph that shows up is going to be called the period, but the letter B is actually going to be called the frequency. So the frequency is how often something occurs, and more importantly, how this is going to be used. So again, is how long it takes for a complete cycle. It deals with that complete cycle, but I'm going to draw an arrow because it's not equal to, but it goes to the period, and the period is going to be 2 pi over that letter B. And that is how long it takes for something to complete that complete cycle that we wrote down earlier. The other part of this we want to be understanding is that letter C. We're going to call this guy the phase angle or the phase shift. Arguably the least important in real life, but still does have application. Letter D going to be the center line. Other books call it the midline. It does not matter which word you use. They mean the same thing. There's really not much else to talk about there. We have these 4 guys. What they're going to do for us is we're going to go ahead and create a little chart for ourselves. This is, again, our same exact thing we had earlier. We had a theta, and we had a sine of theta or a cosine of theta. I'm just going to write f of theta up here. And then we're going to have a couple of lines we're going to draw dotted. We're going to go ahead and draw a dotted line going up and down right here. That dotted line right there is going to be x is equal to a negative c. So it's going to be the opposite of whatever that value is. It's always going to be opposite. Does that happen for x every single time? Just like how you're multiplying by this letter b, you end up dividing over here. Very common concept you'll be dealing with. And then after that, we're going to go ahead and deal with this letter D. I'm going to draw that letter D as a dotted line right here. That dotted line right there, y equal to the letter D, is going to be our center line of our graph. And then I'm actually going to go ahead and draw a little chart here. I'm probably going to need one more color. I guess I'll draw it in red for the actual sine function. So we're going to start it right there, right at that plus sign. And then we're going to go up. And we're going to go down as well. I hope that I have gone far enough. I'm going to go down here below and then up like this. All right. So that's good enough for me. I've gone far enough. You can go the other direction too if you want to in your notes. These should be the same distance. Mine isn't perfect, but so it goes. Other stuff here in pink, the amplitude. The amplitude is the distance from here to here. We call this the letter A. Likewise, it'll be exactly the same distance from here to here, also the letter A, and therefore the entire dang distance must be 2A from the top to top there. By the way, that also means that we can figure out what this top value is up here. Whatever that value is way at the top, this value that it barely reaches is always going to be y is equal to d plus the letter a, whereas that bottom value, however low this guy gets here, is always going to be y is equal to d minus a, guaranteed, because you're going to take that middle value and subtract that distance a to get to the bottom of the graph. I think that is all the information I'm going to need right there. I'm going to draw it in green, even though it's not exactly the frequency. The full cycle, the distance from here where it began, one hump up and one hump down. You also might want to do it instead as a top to a top. So this distance right here, or a bottom to a bottom. All of those guys are going to be a period. And again, it has that formula 2 pi over b. I think I'm done with my notes. I want to get into actually doing the questions, but we'll come back to this page in just a little bit when we're actually doing these things. I suppose I do have one extra piece of information for some students who will prefer to do it. There's going to be a chart you could end up memorizing for sine and cosine. I'll bring that up later. I'm not going to start it here. I want to get into these problems. It's already been 11 minutes. Boom. Let's go into the actual problems, how to graph sine and cosine. Let's do it. So first of all, cosine, we talked about it, how it starts at the top. In this question, it wants us the amplitude, period, minimum, maximum, all these kind of things. So let's go ahead and fill that out. We talked about how that number in front was the amplitude. That's going to be 3. The maximum, that's going to be that center line. In this case, there is no value for the center line. There's a plus 0. So in this case, it's going to be 0 plus 3, which is just 3. And the minimum here is going to be 0 minus 3, which is just negative 3. I'm going to go ahead and mark that stuff up. That means that our graph is going from the center line of 0, which is that axis right in the center there. It's going all the way up to a value of 3. So this is like the top value that it goes to. And it also goes down to negative 3. You do not need these dotted lines in your graph. I just prefer to have them. In addition, it wants us for the period. So we've done the amplitude, max, and minimum. It wants our period. Our period on this one, we don't have anything that is in front of the theta. Because there's nothing in front of the theta, we will say our period is equal to exactly 2 pi. So cosine starts at the top. After 2 pi, you will be back at the top. If you're graphing these visually, the easiest way is by dividing in half and then dividing in half again. What you can do is saying smack dab in between 0 and 2 is 1. That's going to be the bottom of our cosine graph. When you're doing sine, it's a little bit different, because when you're looking at sine, I'm going to go ahead and bring back to this over here. When you're looking at sine, this is our complete distance here, and the halfway mark is back to 0, and then half of that is from here to here. But on this graph, for cosine instead, our top to top, our bottom's in the middle, and then the 2 zeros are dead center on our center line. That's going to give us one cute little period. Try to make sure we are doing everything curvy here. There are no straight lines when it comes to sine and cosine. Everything is curvy. So curvy everywhere. Make sure of those curves. There is one period of cosine. Just to go ahead and complete the graph, I think it's a good idea to do so. I'm going to do so in red, just completing the rest of the graph. So it would kind of go down like this. This part you could actually do perfectly. It would exactly repeat. After half of pi, it will go back down to here. So we'll end up looking like this. But that purple part is the one period. But again, these guys' graph go on forever and ever and ever in both directions. So that should be good enough. So, reminder, if you're doing these problems for yourself, there's going to be that quiz coming up. You want to make sure that you're actually trying it for yourself. Make an attempt on this problem. All on your own. Don't do anything watching a video. Pause the video. Try the question on your own. See if you can graph this y is equal to 2 sine theta. And if you can, great. And if you can't, then watch the video afterwards. All right. Anyways, amplitude. We need all this information. The amplitude is to The maximum 0 plus 2 is 2. The minimum 0 minus 2, negative 2. The period, still nothing to it, still 2 pi. But again, this time we are going up to 2, so I'm going to go ahead and draw that dotted line across it 2 to remind myself that's how high up it goes, and down to negative 2, that's how low it goes. Makes my life easier thinking about it. And then we're going to do our actual graph. Our actual graph of sine starts off at 0, and then 2 pi later, a complete period, you're back to where you started. For sine, you are back to 0 also in the middle, but you go up first, and then down to the bottom in the middle of it. And there is your one complete period. And again, I like finishing this entire chart, so that's what I'm going to do. We're going down over here, back up, back down. It's a good habit to get into, to draw the rest of it. I just said no straight lines, and I made that kind of straight. No good for me, but I'm happy with that. Let's move on to some more difficult questions. For the very next page, we're starting off with something a little bit more difficult. Now we have to deal with these letter B's on the inside. So let's talk about that. We still have to figure out our amplitude. Our amplitude is still regular. Our amplitude is just a 1, which means our maximum and our minimum are both 1. By the way, don't forget there's an invisible 1 in front. So we have that 1, and we have the minimum of negative 1. That's easy, but our period is different. Our period this time is going to be 2 pi divided by a half. So we're dividing this pi over 2, dividing by a half. Dividing by a half means multiplying by 2. That's going to be 4 pi. That means it takes 4 pi to complete an entire cycle of sine. So we're starting off at 0. We do have a top value of 1. I'm going to put that dotted line in. We have a bottom value of negative 1. I'm going to put that value in. And we're starting off at 0, but we have a full cycle in 4 pi this time instead of 2 pi. Just like before with sine, the very middle value is going to be back towards that center. But you go up at the start, another half, and then go down afterwards. We now have a cute little version of this graph. Boom, boom, boom. Easy enough for me. I'm a happy camper. Again, you want to make sure sometimes to actually finish the entire dang chart. I think it is useful for you to do so, but not an actual requirement. So, thinking about it in terms of the visualization, something that's important to note when you're doing things in terms of the value of that is in front, the amplitude, it is a vertical stretch. It's pulling the graph apart basically by a factor of 3 in the vertical direction. Over here, unlike the regular multiplying, these 1/2 do not pull it apart, or the 1/2 does pull it apart, but it pulls it apart this way. If you want to understand the real reason why, the behind it, what's actually happening when you're dividing by 2 is you're pulling the axis apart, which has the effect of stretching the entire thing out. But I think it's easier just to say that when you're dividing, it pulls it apart for the inside, but it squishes it down for the outside. Either way, I'm done talking about that. I want to go on to the actual question. So this one here, still off to 1 as the highest value and negative 1 as the lowest value. Nothing has really changed in terms of our amplitude, max, and min, so we can just be lazy and copy those down. Our amp is 1, our max is 1, our min is negative 1, but our period here is going to be 2 pi over that 4 that is in front, that letter B. That does reduce to pi over 2. Remember, if you're trying to reduce it in your calculator, you are allowed to. I don't think you really need a calculator to reduce 2 divided by 4, but if you are using a calculator, remember to use a 1 in place of the pi when you're using that alpha, y equals enter. That'll make your life easier. But that means the entire problem repeats itself every pi over 2. In other words, it starts off at 0, just like a regular sine function, but the entire cycle is completed at pi over 2. So it will be at the halfway mark, pi over 4, right in the middle, and then we're going to go up here and down here. By the way, half of pi over 4 would be pi over 8. So it goes, and it has this little itsy bitsy guy, and then it repeats itself over and over again. And this one's actually kind of interesting, in my opinion, to do the entire thing of, so I'm going to do it all the way out. I probably should be doing this in red. But you can kind of see how I am going, 0, and then the up, and then the down, and then the 0, and the up, and it just repeats itself in this little itsy bitsy baby section over and over and over again. And that's all this graph is doing. It just keeps on repeating in this little itsy bitsy way over and over. The higher frequency, it has a frequency of 4 times in 2 pi. So let's look at this. 1, 2, 3, 4. There's 4 of those little guys smushed in there now. Whereas over here, it was like half of that guy was in the 2 pi, right? Only the top part. So that's kind of the visual way of understanding that. Let's try the next type of problem. So you're typing this next type of problem. Now we have 3 and 4. Now we have a double whammy. We have 2 things to try to understand at the same time, and that's what we're going to do. So this time our amplitude, yet again, is going to be a 3, which means our maximum value there is 3. Our minimum value there is -3. And our period is exactly the same as the previous problem, 2 pi over 4, which reduces to pi over 2. So for this one, we're going to go ahead and put our 3 all the way at the top. We have that -3 at the bottom. And then it will go ahead and start as cosine. It starts up at the top. But the period of pi over 2, it means it repeats its entire thing within pi over 2. So there's that pi over 2. Halfway for cosine, it goes to the bottom, and an additional halfway are the minimum. So you can see how dang skinny this one's going to end up being. And that's okay. But let's just go ahead and finish this one off. I'm going to do some more values. I'm not going to complete the entire thing because I'm getting lazy. I don't know how long the video's been going, but it feels like it's at least 20 minutes. And, my brain's kind of chilling. Just there we go. I'm going to do that. You can continue doing more if you really wanted to. But yet again, it's the same thing. We're repeating ourselves multiple times. There will be 4 of them within 2 pi, so we already have the top to the top once, top to the top second. There would be 2 more by the time you get to 2 pi. And it goes up and down 3 because the cosine of 4 theta. Number 6, this one's a little bit more difficult. So we still have the same amplitude. We still have the same maximum. We still have the same minimum for this question, 3, 3, -3. But the period this time, 2 pi over b, is 2 pi over 3. 2 pi over 3 cannot be reduced anymore, and none of these values here really are going to be too helpful. So the key thing to remember is that 2 pi over 3 is going to be 2/3 is going to be a little bit less than 3 pi over 4, and it's going to be a little bit more than pi over 2. The idea is this is a half, or about 0.5. 3 over 4 is about 0.75, and 2 over 3 is 0.66. So it's in between those two. In other words, for this particular question, because it's sine, I'm going to go ahead and draw my top dotted line and my bottom dotted line. And again, you don't have to be doing that, by the way. That is a personal thing I like to do. So in between pi over 2 and 3 pi over 4 is this 2 pi over 3. It is going to be a little bit closer to the 3 pi over 4. It's going to be how long it takes to do a full repeat. So there's my first point, and there's my second point, about right there. So there's my full repeat. Halfway in between that is going to be my not so much. Half of 2 pi over 3 would be just pi over 3, or a little bit less than pi over 2, because we're doing halfway in between here. But this one's going to be slightly closer to the pi over 4 value. So there's our halfway mark. And again, that would be pi over 3 if you were really trying to do it by hand. And then half of that would be pi over 6. So again, you need to do half of that. Sine goes up at the start, and then down later. Where would the next one be? So it would be in between pi over 3 and 2 pi over 3. We're adding a 6, so 5 pi over 6. So 5 pi over 6, would that be more than pi over 2? Most definitely. So it'd be like down here, I suppose, and it would look like this. That looks pretty decent. And it would just repeat itself over and over. So again, that was a little bit more difficult. If you wanted to figure out the exact kind of thinking about it on a number line, I think this is one worth kind of attempting to do, and having that understanding of the fraction part of this, where the division's happening. So you're going from 0, and we're going to go to 2 over 3. Technically, there's a pi on each of these, but I'm not going to worry about that. And that's going to be our complete cycle. Halfway in between that is going to be a third, and halfway in between that would be a sixth. And halfway in between this is 4 over 6, right? And this would be, oh, whoops, this would be exactly a half, wouldn't it? Sixth, a sixth, a sixth. Yeah, it would be exactly at half. So mine was actually off by a tiny bit. It should be exactly at that halfway mark. I don't know why I did that a little bit wrong. But the point is this is where you're kind of thinking about it with your pies. If you're trying to do it as nice and neat as possible. If you would like to do this on a calculator because you're struggling with it, I should be grabbing my calculator here somewhere. I'm going to pause the video so I can find it. Anyways, the video is continued. If you were trying to do any of this in the calculator, so you have this like 2 pi, you're starting with a 2 pi, and then you're dividing by 3, alpha y equals enter, 2 divided by 3. There you go. There's your 2/3 that you're looking for. We know the halfway mark will be halfway in between that, so you could divide by 2. So that's going to be the 1/3. And if you want to do another half of that, you could divide by 2 again, and that'll give you the 1/6. If you really wanted to figure out where that 1/2 is, we would have to add a sixth twice. So plus 1 divided by 6, that'll give you that 0.3 again, plus 1 divided by 6, that'll give you the exact 0.5, and you can hit math, enter, enter to get that fraction value down. A little bit annoying, a little bit difficult, but definitely doable, you know. And this brings us to the idea of the chart, if you want to do the chart version. So if you're looking for a chart version of this, you definitely can. So the chart version of all these questions, there's going to be sine and cosine different one, but we have like a regular old chart for x and sine of x. Our regular old chart starts off at 0. At pi over 2, sine goes up to 1. At pi, it's back to 0. At 3 pi over 2, it's down to -1. And at 2 pi, you are back to 0. So if you're trying to do it in this way, and you're going to convert it into a new function here, in this one, we have x and 3 sine of 3 theta. So if you're looking at it from the perspective of how we used to do things like I can't speak. When we used to do our transformations for the A, B, C's, and D's, we talked about how the letters A and D affect the Y values, and the letters B and C affect the X values on the inside of that. So I'm talking about if Y is equal to what I wrote down at the very start of my notes, A times the sine of BX plus C plus D. These two on the inside of the parentheses affect the X values, and these on the outside affect the Y values. So the A here, all these Y values are getting multiplied by 3. So we're simply going to have 0 still, and then 3, and then 0 still, and then -3, and then 0 still. Whereas the ones on the inside will be dividing. So you're dividing all of these by 3 instead of multiplying by 3. So you still have 0, and this is going to be pi over 6 because we're dividing by 3, pi over 3 because we're dividing by 3. The 3's cancel, so you get pi over 2, and then 2 pi over 3. And now you have this list of coordinates that you could actually just play connect the dots with if you really wanted to. But I do think the visual way of graphing it is going to be easier. This has been a lot of information. I'm going to try yet another version of this in just a moment, but we're going to go ahead and finish up these problems, do the hardest types coming on up. Here we go, numbers 7 and 8. By the way I did this one, we have, again, that goes from easiest to hardest. So now we have a third letter introduced. We have that letter D introduced into the questions. So a couple of things. First of all, we have that 1/2. The 1/2 is our amplitude. Our amplitude is a half, but our maximum is going to change this time. And the reason why our maximum is going to change is we have this +1 out here. So our maximum is going to be 1 plus a half, and that's going to be 3 over 2, or a 1.5 if you'd rather prefer decimals. And likewise, our minimum is going to be 1 minus a half, or just a half, or a 0.5 if you're so inclined. Our period will be the same annoying one as the previous question, 2 pi over 3. Now, our 1 right there out here in front is going to cause us to have a center line at a value of 1. But we're only going up a half. So I'm not even going to be able to draw it to a dotted line because it's going to make it really, really nasty looking. We're going to do our best, though, to do the entire thing. So we have a 1/2 there, just like the previous question with 2 pi over 3. We're going to be a little bit over here for our full up and down, and then halfway of that. And then we go all the way down to 0.5, and we are going up to 1.5. It's supposed to be a 1.5 there. And you can see how small this guy is because it's got that 1/2 in front. So it's going to look just like this. And we could, again, continue doing more and more if we felt like it. This one over here, yet again, we have this -2 that's going to be our new center line. So now we have that same amplitude. Our amplitude's a half. Our maximum here is going to be -2 plus the half, which is -3/2, or -1.5. Our minimum is going to be -2 minus a half, -5/2, -2.5. And then our period, this time 2 pi over a third, which is 6 pi. This is going to be a huge graph by comparison to the last one. It takes 6 pi to do a complete cycle. So we start off again at the center line for sine, and then it takes all the way to 6 pi to complete the entire thing. Halfway, we're at the halfway mark, which is a 0 for sine. And half of that, which would be in between pi and 2 pi, will be at the highest value, which is -1.5. And then halfway in between that, 4.5 will be at that lower value. Whew. There you go. Easy enough. Let's move on to the last one. Now, admittedly, these are going to be the more difficult ones. I will not put this on the first set of problems. The reason why this one is so difficult will be clear in a second. The main thing is that all of these are going to have y is equal to a times the sine of b x plus c plus d. If you notice, I am missing a parentheses on the inside of this. So before we even start, we need to rewrite this by doing some factoring. We're going to factor out a 1/4 because that is what is in front of theta. So we have a 1/4 theta. And that 1/4 is going to cause some other interesting things to happen because this pi/6 is occurring. Now we're multiplying by 4 effectively because we're dividing by a fourth is multiplying by 4. Multiplying by 4 is going to give us 2/3. And again, to double check your work, you could multiply this back out and get to it. If you wanted to check out how you could have done that on a calculator, if you're struggling with it, you do alpha y equals enter to get the 1 divided by 6. I'm not putting the pi in there because I'm going to have pi in my final answer. And then I'm simply dividing that by 1/4. And if I divide that by a fourth, you'll see math, enter, enter. If I convert it to a fraction, I get 2/3. And that's exactly what's happening there with our minus 2/3 pi. So we have a couple of different pieces of information here. It means that we are having our center line is back to 1. Our max is the same as the last question. I'm not going to show all the work for it, but we get to a 1.5. Our minimum is going to be a 0.5. But this time we have that phase angle. So we have this phase angle here. The phase angle is equal to 2 pi/3. That's opposite sign of this minus sign. What that means is it's where the graph is starting. The graph is going to start at 2 pi/3, which is going to be a little bit over here. So it's going to be kind of right in the less than pi because it's 2/3 pi. So it's going to start there as opposed to where it's been starting. You will still have the same period formula. The period is going to be 2 pi over b, which is 2 pi over a fourth, though you can't even see what I'm writing. And that's going to give you a total of 8 pi. Now that's how far we're going to go. We're going to go 8 pi more than 2/3, so a little bit more than the 2/3. There's our full repeat. Halfway, right there at 4 2/3. Half of that would be 2 1/3. I don't know why I put it on that. It's got to go up to 1.5. I apologize for putting a dot there when I shouldn't have. And then, where would this one be? It would be exactly, because we had the 1/3, 2/3. No, half of that, right? My brain is failing. Pausing for a second, my brain stopping. Yeah, so it would just be halfway of that. So again, this was 8 2/3. This was 4 1/3. This was 2 1/6. So over here, we're going to have 6 1/2. And there you go. All right, and we got one more to try out. Let's do it. So this one, yet again, we have that factoring, but the factoring is easier on this one. 2 times the sine, we got a 1/3 theta plus pi this time, minus 2. That means we have a phase angle of negative pi, so I don't know why this graph doesn't have the completed value. I really wish it did, because that's where we're starting our graph off. Our graph is starting at negative pi over here. So we're starting at negative pi, and then we're beginning at negative 2. Our amplitude here is 2. Our maximum is going to be negative 2 plus 2, or 0. Our minimum is going to be negative 2 minus 2, which is negative 4. Our period going to be 2 pi over a third, which is 6 pi. And then we have that phase angle again. The phase angle is going to be equal to negative pi. So we're starting here off at the 0 marker. It takes 6 pi, which would take us all the way to 5 pi for that one. Halfway in between negative pi and 5 pi would be 2 pi. So that's our minimal value. And then it goes up to 0. We wrote that as our maximum. And down to negative 4. That's what we wrote as our minimum there. And there you go. I'm a happy camper. Have a great rest of your day, guys. Peace.